All right, so welcome everyone to the Intermediate Linux short course for FASTR and ACES. So hopefully everyone has, this is an intermediate Linux course. Hopefully everyone has some experience with the basic Linux commands. Maybe you've taken our Introduction to Linux short course or you're familiar with it already. So a brief overview of what we're covering. We're going to go into a bit of detail about text processing. Hopefully it's a bit more than what was covered in our previous course. Then we're going to go into bash scripting, a couple useful commands and how to create bash scripts and use a calculator within the scripts. And then lastly, we'll end up with some details on setting up your Linux environment. Okay, so before we begin, there is a directory on FASTR with some files, example files that we're going to use. So please take a minute now to log into FASTR via your preferred method. And if you're having issues with that, please let us know. Navigate to your Scratch directory and then copy the practice files from this training directory into your Scratch directory. So just take a moment and do that, and let us know if you have any issues. So I just copied that training directory over into my own Scratch directory, and now you should be able to see some example files here, as well as the solutions to some practices that we're going to do. So if you're having trouble on these practices, feel free to look at the solution, but we will cover it after each practice as well. Okay, so this first section is over text processing. So the goal here is to gain some basic usage of VI to edit text files, as well as to use some of these common stream editors, sed, awk, and grep, which really make text processing and parsing files a lot easier. So we're going to go through the basic commands for these and then do some practices. So starting with VI, the first command you need to know is that VI space and then the file name will open. It'll open a file if you have a file available in that directory. If you don't, it will create a file with that file name. So you can use it to create a file or to open an existing file. If you use this -r input, then it will open the file in a read-only mode, so you won't be able to edit it. And then view file name is just another alias for vi-r, so it'll do that same thing. So a key thing to know in VI is that there's two main modes. There's the insert mode, and this is how you edit the text file. You can insert text, and it's done with I. We'll talk more about other commands to open this later. The other mode is command mode, and this is for navigating the file. You can do some additional commands other than just like inserting text, and we'll cover some of the cool commands that you can use that really make your life a lot easier when processing files in command mode. But one thing to always make sure when you're using VI is what mode you're in. So if you're having trouble typing in text to your file, it might be because you're in command mode. And if you're having trouble running commands, it might be because you're in insert mode. So that's always something to pay attention to. Hopefully you're in that practice directory that we copied over. So try creating a file now, just using the simple VI command. You can put your own file name in. You don't need to use file name, but just try making a file now and opening up VI. And I'll be doing it over here as well. So I'm just making a file called testfile.txt. And you can see when I type that in, it opens up VI in my terminal. So you should see something similar to this. Your own file name will be down here at the bottom. Okay, so when you first type in this command, you will start in command mode as opposed to insert mode. So if you tried typing something right now, it wouldn't put any text in your file. If you ever want to return to command line mode, you can press escape as well. So how do you know what mode you're in? The first command you can do is to type it while you're in command mode, :set, and then space show mode. And this should display, the current mode in the lower right-hand corner of your screen or of your terminal. However, I do know that there are some issues with some terminals depending on how you're accessing faster and what terminal you're using with this command. I don't think it shows up on my Mac terminal. So another way to know is if you're in insert mode, like I am now, you'll see down here at the bottom it says insert. And if you're in command mode, it doesn't. So that's just another way you can tell what mode you're in. Okay, so the most important thing to learn when you're using VI is how to exit VI. If you don't know, it can be quite frustrating. So there's a couple different commands you can use, and sometimes in VI, there's multiple commands like this that will do the same thing. So you can do capital Z, you can do :WQ, or you can do :X. What these do is save the file and exit. So you should only do this if you want to keep the changes to your file that you've made, because this will save those changes. :W space file name will save the file with a new name. :W exclamation mark will force save. So that's the exclamation mark will always force what you're trying to do. So in this case, :Q with the exclamation mark will quit without saving. That'll force quit. Normally, if you just try to do :Q, it'll try to quit. But if you made changes, it'll give you a warning that your file has been changed and it won't let you quit. So for example, if I made some changes to my file and I tried to do :Q, it'll say this warning down here, error 37. And if you want to force quit, you have to add the exclamation mark like this. So :Q exclamation mark. Okay, :Q quits if there's been no changes, and yeah, :Q exclamation mark quits regardless of changes. So if you've made a mistake while to your file, while editing, and you don't want to save your changes, you'll want to use :Q exclamation mark. So try writing something and then closing the file you've created. And you'll either need to use save, file, and exit, one of these commands up at the very first line, or you'll want to use :Q exclamation mark. So hopefully you were able to exit VI. So here we're going to go through some VI commands. If you want to practice these on a text file, I have this file example or ex01.txt in the directory that you should have copied over. That it's just a large text file that you can use to navigate and practice some of these commands. So if you open that one up and share the screen at the same time. So hopefully you can see my terminal here and the slideshow. So I've opened up the text file, and now I'm just going to practice some of these commands. So you can navigate with your arrow keys, or you can also navigate with H, J, K, and L, and they kind of work the same way. So you can move your cursor around your text file. Typing G will move to the very end of your file. So you can see this file down here. It's showing the line count. So there's over 100,000 lines in this file. So that would take a lot of scrolling if you wanted to go to the bottom. So typing G, capital G, will move you very quickly to the end. You can go to a certain line by typing the number of the line and then G. So if I wanted to go to line 100, good, type 100, capital G, and go to that line. There is another option for that. You can also do a colon and then a number. So if I did :200 and enter, it also goes to that line. You can do the control key and F to scroll down one full, terminal screen. You can do control and V to scroll up a full screen. 0 will move you to the start of the current line. So if I'm, in the middle of the line, I hit 0, it'll move me back to the start. W will move forward a word, B will move back a word, and E will move to the end of a word. So these are just some basic navigation commands. These are all done in command mode. Of course, if you try doing this in insert mode, you would type these commands that you were trying to put in. Okay, so there's several ways to go from command mode into insert mode. So the easiest one is I, which will put you in insert mode and keep, let you put text immediately to the left of your cursor. Capital I will move you to the beginning of the line. So if you did that, you'll go into insert mode at the beginning of the current line you're on. A will allow you to, it'll move you into insert mode and it'll put the text to the right of the cursor. So now you can see it moved me to the right of the cursor. Capital A will do the same, but at the end of the current line. O will go into insert mode, but also insert a new line beneath your current cursor. Capital O will do it above your current cursor. Capital R will overwrite text to the right of the cursor, and CW will change a word with a new text. So by the way, I know this is a lot of information, a lot of commands. You can always go back to our slides and view these. But hopefully from this, you can practice these and just get a basic grasp of what to do. And you don't always need to use all these commands. I mean, I almost always just use undercase I to go into insert mode. So don't worry about memorizing all these if you don't need them. Just try to learn what you'll need. Okay, so let's do some practice here. This is pretty simple. Just open up a text file, go into insert mode, type something, say in this case, hello world, and then save and exit the file. Once you do that, you should be able to see it in your current directory and view its contents. So take, just 1 minute and try to do this. Shouldn't take too long, and then we'll go through it together. Okay, so hopefully everyone got this practice to work, but I'll just walk through it very quickly. So we'll just open up a new text file. I'll just call it PI example. We'll go into insert mode by hitting I. Type in some text. We'll then save with :WQ. And now I should be able to see this file that I just created. It's this example.txt right here. And if you type more and then that file name, you should be able to see the contents of the file. Okay, so pretty easy example. Hopefully no one had any issues. Okay, a couple more commands. Actually, I'll keep my terminal showing here, so we can go through some of these. Okay, these are commands that you execute in command mode. They will keep you in command mode. I'll go to example 01. Okay, so delete a single character at the cursor. You can just do this by pressing X. Oops, I'm in insert mode, sorry. So you press X and it'll delete that. 2 undercase Ds, I use this one a lot. It'll delete the current line. So that's just a really easy way to remove whole lines from your file. You can delete more lines by typing a number and then that. So here I'm deleting 3 at a time. DW deletes a word. D capital G deletes to the end of the file. So it's a dangerous one. Capital D deletes to the end of the line. So that'll do the same thing as the 2 undercase Ds. R and then A will replace your current character with A. So it could be something else. So like if I did R H, it replaced that 2 with an H. U will undo your last command. So you can see I can press this and it will undo all the commands I just did. On Unix machines, it might only save 1 undo, but on these newer versions of VI, you can do multiple undos. In like a number and then 2 undercase Ys will yank a certain amount of lines to memory. So if I did 3 Y, you see here at the bottom 3 lines yanked, and then P will place them back here. See, I'm placing those lines that I yanked. back into my text file. Lowercase p puts them below the cursor, and then uppercase p puts them above. Sorry, it's kind of hard to see here on the slides. Okay, so those are some very useful command mode VI commands that really will speed up your text processing. Okay, here's some miscellaneous commands that are also very useful. Some of this functionality I think can be done easier with some of the other methods I'll talk about later in the course, but you can also do it from VI. So, another option. Okay, so a / and then a string will search forward for that string. A question mark and then a string will search backwards for that string. Okay, :1, comma, $, and then this this format, which you'll see later as well in some other commands, but S and undercase S / one pattern / second pattern and then /G will go from line 1 to the end of your file and substitute all instances of pattern 1 for pattern 2. The G will, if you don't have the G at the end of this command, what it will do is it will only substitute the first instance of pattern 1 in a line. So if you have pattern, that string repeating multiple times in your file, and you want to, or not multiple times in your file, but within the same line, and you want to replace all of them, you'll need to add the G. Okay. :E exits to the file name or whatever name you have there. MA will mark a line and store that position in a variable called A. So then if you wanted to use that variable again, you could use it as in these other commands, : quote, single quote, A, comma, period, Y, and A. So what this will do is this will yank the lines between your previously marked variable A and to where your current cursor is and store that in variable X. And you can kind of see the syntax there and how it executes that command. : P and U will put those certain lines stored in X into a file where the cursor is. : R will read a file, named file name, and insert it after the current line. : set and then space all will display all your current VI settings, and then : set space number will display line numbers in your file. Okay, so these are just kind of some general miscellaneous commands, but you may find them useful, especially the pattern search and replacement. But like I said, you can also do these with set and some of the other commands we're going to be talking about. So there's multiple ways to do some of these. Okay, so let's practice some of these. And of course, if you want to go back to these commands, I believe we have a link to these slides. Are they posted in the chat? Could someone post maybe the link to these slides in the chat so people could go back to the previous slides to see some of these commands? I believe it's hprc.tamu. Oh, there it is. Okay, so you can click on this link and see a copy of these slides, so you can go back and look at these commands while you do these practices. Okay, so in this one, open up the file example1.txt. You'll use this command wc-l. So this counts, it can either count the number of characters, words, or lines in a file. The -l will ask it, it'll tell this command to count the number of lines in a file. So if you type this, you'll see how long this example1.txt file is. And the whole point of that is just to see it's like over 100,000 lines. It's much too large to go through and search for something by hand, right? So you'll want to use these commands. So you'll search forward for this string atoms in the file, see what line it's on, and then practice some of these basic commands, delete the current line, jump to the end of the file, and then jump to the beginning, and then quit. So take 2 or 3 minutes now and try to do this practice, and then we'll go through it together. And let us know if you have any questions. All right, everyone, so I'll walk through some of this. Oops, sorry. Okay. So first I'll open up the file, example 1. Oh, wait, sorry. First, I will use the command wc-l and see how many lines are in the file. So you can see here there's over 100,000, so much too large to search through it by hand. So /atoms searches forward and we'll find this here. Oops. And you can see here it's on line 2915. When you're searching through, if you hit N, it'll go to any other instances of that string, but in this case, this is the only instance, so hitting N won't move the cursor. This command will delete that line. The next command, G, will jump to the end of the file, so here it puts me at the end. 2 lowercase g's will put me to the beginning, and then to quit without saving, just Q, and then exclamation mark. All right, so pretty simple example. Hopefully that went well for everyone. Okay. So beyond using VI, there are some other very useful tools. So the first one is called SED, or maybe some people call it SED, but it's a stream editor. Okay, so what this will do is do some basic transformations on your text file, and you can either do it as a pipe from another, terminal command. Hopefully everyone knows what a pipe is from our, first course, but if you're unfamiliar, basically pipe will move the output of one command into another command. So the command man displays some user manual information about commands. So if you type in man and then SED, it'll display some basic user manual information about it. But sometimes that's some pretty basic like descriptions of information. So not always that useful. If you want more info, you can look at some of this online manual and documentation links we have here. Okay, so here's some common uses of sed. The first is using sed-n, and then in single quotes 4, or 4 comma s, that'll print out lines 4 to s. I'm sorry, 4 comma 6, that'll print out lines 4 to 6, and then under case b. And so this is very useful if you just want to print out a certain amount of lines in a file name. The same thing, but with a D instead of a P and without the -n, we'll delete lines 2 to 4. So if you also just want to delete a single line, you can do like 2D or 4D, and that will just delete line 2 or delete line 4 or so on. And then if you want to delete from a certain line to the last line of a file, you can use this command here. So 3 or n comma $D, and that'll delete from line in to the very end of your file. And we'll practice some of these in a couple slides. Okay. So the most useful, in my opinion, thing to do with sed is substitutions. So if you type in this command, and it kind of has the same syntax as what we had in VI, but sed and then single quote s / pattern1 / pattern2 / g, and then another single quote, and then your file name will find and replace all patterns of 1 with 2. If you add this greater than sign, and then another file name, it will copy the output to another file. Another option is to use this -i after sed, and what that will do is we'll modify your file in place, so it'll edit the original file. Some other options is that if you use this, I always forget what this called, like caret top symbol, then you can replace pattern 1 at the beginning of each line of a file. And if you insert a $, it'll place pattern 1 at the end of each line of a file. And so I think this is using sed is one of the most efficient ways to do find and replace in text files. So we'll do some practicing with sed here, and we'll use example file 2, so ex02.txt. So just in your terminal, without opening it up in VI, see if you can do the following commands. And I would recommend copying this to a temporary file just so you don't accidentally delete the original file if you make a mistake. So replace all instances of the word vegetables with cheese, even if it appears more than once in a line. So remember, that's remembering to put that under lowercase g at the end of that command. Then delete the first line of the file, and then delete the second line and then the fourth line. So don't delete them all at once, or else it won't delete the lines correctly. First, you have to delete the first one, and then delete the now second line. So it would have been the third line before you deleted the first one, but now it's the second line, and then delete the now fourth line, and then print lines 1 through 4 and save to a file called output.txt. So you should be able to do this all just with sed. Okay, so first I'm going to make a copy of this file. Oops, sorry. So you can see it's the same file that we had before. And it's just a list of random words I pulled from a random word generator. Okay, so what was our first objective here? Replace all instances of the word vegetables with cheese. So I'm just going to do it in file with the -i, and then s for substitute, vegetables, cheese, and then don't forget the g at the end. And then we'll add this. And now if we look at that file, you'll see now it says cheese everywhere. It used to say vegetables, even in the case of this line where it was in there twice. Okay, so now we're going to practice deleting some lines. So let's delete the first, then the second, then the fourth line. So I'll do it in file again. So first I'll delete the first. And now you can see this line at the very top was deleted. And then I'll delete the second and the fourth. And now you can see this is what we're left with. Now print lines 1 through 4 and save to a file output.txt. So that was this command here. So there should be 4 lines if I do wc-l on output.txt. Oh, maybe not. Really do. Oh, I already had a file name, output.txt. Let me do that again. Oh, I'm sorry. I forgot the -n, of course. It even said so. Yeah, thank you. Thanks, Michael. Okay, there we go. So now it's 4 lines. So yeah, it even said here, and I forgot it. If you don't add the dash in, then line 4 to 6 will be printed twice. Okay, so pretty simple example. Hopefully no one except me had problems with that. Okay, the next very useful tool is called awk. So awk is used to search, or AWK, it's used to search for lines or other patterns of text that contain certain patterns and do something to it. So we can print it, we can manipulate it, we can do some different things. Okay, so here's kind of the general syntax of using awk. So type the command, then you'll type any options, and then single quote, the pattern you're going to search, and then the actions you're going to do on it, and then end quote, and then the input file that you want to perform these actions on, and then you can save it to an output. So this variable fs, which is the field separator, the default is white space. It's like a space or a tab, or something of that nature. You can put a custom field separator in, but if you don't, the default will be white space. So, for example, if you wanted to search for a certain pattern, you would do this command here, awk quote / pattern / quote, and then the file name. And then it'll save these as variables. So if you wanted to access, the entire line, you would do the variable 0. If you wanted to do just the first field, it would be the variable 1. And if you want to do the second field, it would be the variable 2. So in this case, these would appear as columns. So if you wanted to print out this entire shopping list.txt file, you could do awk and then print, and then this 0 variable, and you would print the whole thing. If you just wanted the first column, you could do print and then $1. If you just wanted the second column, you could do $2, and so on. Okay, some other variables. There's nr for the total number of records, nf for the number of fields in a record, rs is the record separator, fs is the field separator, OFS is the output field separator, and ORS is the output record separator. So one of the most common uses of awk is just to print out, columns. So this is how to use that print statement. So this would search through your file name for a certain pattern and print out every line where it finds that pattern. This would do the same thing, but in the second statement, now the field separator would be a comma. So in the first one, it would just use the default white space field separator. And here in the second one, it would use the comma. If you want more control over print, you can use, you can check out this link, and you can use this printf statement. I usually just use the print statement, however. You can do some pre and post processing. So if you use this begin command, all in caps, then it'll add to the very first line something, as in this case, it'll add the word or the string shopping list in line 1, and then the other variables after that. And then end does the same thing, but it adds a line to the very end of your file. So in this case, it would print the number of records at the end. Okay, so we'll do some practices with this. Okay, so print the third column of the temporary.txt file created in the last practice. Well, I guess you can take a second and try it yourself. I don't know if the temporary.this file, tmp.txt, will say anything. I think if you do the output.txt file, it'll make a sentence, but yeah. You can try these too. It should just take a second. So in this case, we're not searching for any particular pattern. So you won't have this initial pattern command. It'll just look like this, awk. Then our command print, we'll want column 3. temporary.txt. So you can see this is just that third column of what we had in tmp.txt. I think if you do it with output, you get a little sentence here. So And if you wanted to save this as something else, you can just use this greater than sign and then a new file name. So pretty simple hands-on exercise there. But that's the basic usage. If you wanted to print the whole thing, then you could use the variable 0 instead of 3. Right here, and now it prints out everything, the whole line. Okay, so that was basic awk usage, and now we'll introduce the grep command. Now, I believe we kind of covered a little bit about this in the Introduction to Linux course, but I have a little bit of additional usage to show here, so hopefully you'll learn something. Okay, so grep will search for a certain pattern within a file and display, the lines containing that pattern to the output. So here's the basic usage, grep, and then the pattern that you want to search. So in this case, it's energy, and then the file you want to search for it in. So in this case, it's run1.out. This is case sensitive unless you use the -i flag, and then if you use that, it will be case insensitive. If you use a wildcard, so in this case, grep energy, then wildcard.out, it'll look through all your files that end in .out and display where it finds this term energy. Oh, I'm sorry, I went forward one. Okay, if you use if you want to search for a pattern that has some blank spaces, say you want to search for multiple words, then you should use quotes around your search term. And this example will also search through all the files within each directory in the current directory. If you use the -r, it'll search recursively for all files within a certain directory for the pattern that you're searching. Okay, a little bit of additional usage here. So if you use -A, it will out, and then in, it will output in lines after each line containing the search term. So say you don't only want to see the lines that contain a certain word, you want to see the lines after it that contain that word, you can use -A. -B is the same thing, but it looks for lines before each line containing a certain word. And -V outputs lines that do not contain the search term. So somehow, like how I use these sometimes together is if I want to only show the line after a certain search term, I will do grep-A and then, in like 1 to show like one line after the search term. And then I'll pipe that into a grep-V with the same search term. And that will only display the single line after that term. Okay, if you want to search for multiple patterns, you can use egrep. So in this case, here's the syntax. So single quote, pattern 1, pipe, pattern 2, pipe, and then so on. If you can search as many as you want there. In quote and then the file name, and that will search for all those patterns. The pipe key is this one located here. So here's an example of that usage. egrep, energy, pipe, enthalpy. We'll search for the word energy or enthalpy in every file that is .out, is what that command is saying. Okay, so let's do a bit of practice with grep. So use grep to count the number of lines either containing the pattern min or max in example file 3. And maybe then you can use wc-l to see how many number of lines that is, if you wish. And then this is kind of the use case I was describing before, but using only grep, print only the line after the line containing love in the file ex02.txt. So that's where you string together grep-A and grep-V. So our first task is to count the number of lines containing either min or max in the file example 03. So we'll use egrep so we can do multiple patterns. Min, pipe, max. Oops, I forgot quote there. Oh, that one too many pipes. sorry. There we go. So these are all the lines that contain those patterns. If you wanted to count it, you could pipe that into WC-L. So 26 lines with that pattern. And if you just wanted to do one of them, you could do it with grep, just like that. Okay, our second task was to, using only grep, print the line after the line containing the pattern love in file example 2. So here's this. So we want this line right here, the one that begins with piano. So if I do grep -a1 love, this will print this line with the word love and the line after it. And if you pipe that into -b love, now it will print all the lines that do not contain that phrase love. So we're just left with the line after that phrase. So that's just a little example of how you can pipe, commands like grep. You can also, use it with awk and sed as well to very quickly process large text files. Certainly very handy if you're doing a lot of data analysis on maybe text files and you need to just grab certain lines really quickly or certain columns. So now we're going to begin the fun part where we're going to do we'll learn a little bit about bash scripting, and then we have some fun, scripting practices to try, some little challenges. So, all right, so our objectives here is to understand conditions, loops, and make bash scripts for simple tasks. Okay, so a shell script is a text file that contains one or more Linux commands that can be run as a single batch of commands. So they can be used to automate routine tasks. And general practice is to, in the name of shell script, files with .sh, just so you know what is a shell script and what isn't. So what you see down here is an example of a shell script. So we'll kind of talk about what these mean. So up here, the pound and then exclamation mark and then /bin/bash. This indicates what shell you're using. So in this case, it's using bash. So the shell is going to ignore blank and commented out lines. So it'll ignore these line 2, 3, 5, and 7 here because they are commented out with the pound sign. And so you can see what's actually happening in this script is that a variable, in this case, current user, is being saved as the output of a command. This is a command called whoami, using the $sign and parentheses. So that will store the output of a command as a variable if you use this format. Make sure you don't add spaces after the equal sign, or that will cause issues when you're storing a variable. And then it's running a grep command down here. You can see it's using a grep command with that variable. Okay, so this is just an example of a short bash script to get kind of the format down. So you run a bash script with bash and then the file name. If you want to add executable permissions to your script so it can be run with like // and script name, you can use the command chmod. So chmod u + x script.sh, or I often use chmod 755 and then script.sh. But both will add executable permission for you to run your script. Okay, so basic constructs for bash scripting. So the first one is a conditional. So, if something is true, do something or some command, and if it's false, do something else. So basic if-then statement. So this is how it works. You'll have if and then some command, and then on a new line, then so if you see a semicolon, that is basically telling your bash script that what comes after that is on a new line. So in this case, these are kind of equivalent, the left and right side here. Okay, so then some commands, else if, some commands, then do something else, do something else. And then you end with fi. So you start with if and you end with fi. So if you look on the right side here, you'll see an example of a small script that tests if I is equal to 1. So it assigns variable I to 1, and then it says if, and then variable I equals 1, then write to the console I is equal to 1, or else write that I does not equal 1, I equals, whatever it equals to instead, and int if. So that's an example of a very simple if-then statement. Okay, so in that example, they use the -eq to say is equal to, but there's a lot of other comparison operators you can use. So yeah, is equal to is with -eq, and that's also the same as what you see on the right-hand side of this column. So this is kind of on the right-hand side, this is kind of how you would use this comparison operator. So this is kind of what you saw in the last slide where it was saying, go back, if the variable I is equal to 1 in brackets, that's kind of what you see here. I would always make sure that the spacing can affect the script. So make sure you have, one space here before and after the brackets. Okay, -ne is not equal to, -gt is greater than, -ge is greater than or equal to, -lt is less than, -le is less than or equal to. You can also use the less than or greater than symbols. There's slightly different usage for these, so you'll see on the right-hand side that you'll use these double parentheses instead. You can use that also with less than or equal to and greater than or equal to. Make sure it's within the double parentheses. Okay, string comparison operators. You'll want to use these here. So double equal signs can be used in a couple different ways. So here on the right, you can see some different usage of double equal sign. So, true if the variable a starts with a z, in this case, the z wildcard within the double brackets. True if variable a starts with z star. So this is literal matching. So it's looking for z star. In this next case, it'll split. So it'll look for that variable being equal to z, but it's going to split this up into separate words if it's separate words. $, okay, variable a is equal to z star. This once again is literal matching. It's the same as above. Okay, exclamation mark and equal sign is not equal to, and then greater than, less than symbols, using, I guess, ASCII alphabetical order. -z will check if a string has 0 length, and -n will check if a string is not null, so it has more than 0 length. So that's some basic usage for if-then statements. Okay, constructs. So if you don't want to do a if-then statement, there's also the opportunity to do case constructs. So if this is the basic usage, if you have a variable, case that variable in whatever the first case is, then do a command, then double semicolon. Case 2, execute some command, double semicolon, and then the stars for the default case. So everything else do some commands. So you can see here, this is a script on the right-hand side that's labeling months. Depending on what month it is, it will assign a variable a number according to that month. So, variable month is equal to June. Case variable month, and then you can see it'll say for January, assign this variable m num equal to 1. If it's February, assign it to 2. If it's so on and so on. If it's December, assign it to 12. And then you end it with case backwards. So that's how you could do a case construct instead of like an if-then statement. All right, so let's practice some of these conditionals. So this is a fun little challenge. So create a shell script that will check the current day on the system and see whether it belongs to the first, middle, or last part of the month. So if it's within the first part, the first 10 days, we're going to echo we are within the first 10 days. If it's not, check if it's less than or equal to 20 and then say we are within the middle 10 days. And if not, then obviously we're within the last third of the month. So then return we are within the last third of the month. The command to check the current day of the month is date plus percentage %d. Make sure you notice there's a space after the plus, and that will return the day of the month. So it should return 27 for today, and you could test that. So yeah, let's take maybe 3 or 4 minutes and try this example before I'll walk through the solution. If you're having trouble, you could wait for me to walk through it, or you could check I have the solutions already in the file that you should have copied over. So that's another option too, if you just can't wait. But yeah, take a few minutes and try this example on your own. All right. Hopefully you had a chance to get this to work, but if not, I'll work through it right now. So I went ahead and did the solution to this one in the file conditionals solution. So we can open this up and take a look. So the first thing I do is assign a variable to today's date. So this date plus and then percentage mark, I guess I forget the name for that symbol. D will give us today's date. You could also do the method to store variables that we described earlier with the $sign parenthesis, double parentheses. I'm sorry, single parentheses. But in this case, the back quote also does the same thing. It'll execute that command and store the variable to that executed command. Okay, and now just go ahead and print, what today's day is. And then here's the if-then statement. So what I do here is I have one if statement. If today's date is less than or equal to 10, then I print today, the, say 27th is in the beginning of the month or whatever it would be. For the next statement, and there's a couple different ways you could have done this, but I used if the date is greater than 10 and the conditional if the date is less than 20. So to do this, you have to do double brackets so that you can get both conditional statements to work. And then remember this colon just tells it to put then on, read it as if it's on a new line. So if it's greater than day 10, but less than or equal to day 20, then I echo or I print it's the middle of the month. And then if not, then it must be, between 20 and 30. So then I say it's the end of the month. And then you end it with FI. So you can run this way. And today's date is the 27th. It's in the ending third of the month. I guess I didn't quite put the whole print statement here. I guess it should say we are within the last few days of the month. Okay, and you can also just test it. If we wanted to test if it worked for the other days, I could just say days equal to say 10. Now it should say it's in the beginning of the month. So yeah, so today the 10th is in the beginning of the month. And if it was 15, it should trigger the second conditional statement. So it should say middle of the month. And that works too. So this script is just a basic, usage of the if then statement. And there might have been some slightly different ways to do it, but hopefully you got that to work. If you had any issues, be careful with the having spaces. Like if you have spaces, sometimes after the variable assignment, like it could cause it to not work if you had a space like that. If you mess up the spacing, like I think if you have it like this, it might not work within the if-then statement. So just a couple things to double check. Yeah, so this one within the bracket, it messed that up. Having deleted those spaces there. All right, how to do inputs from the command line or outside the script. So if you wanted a command line, or if you wanted to input from within the shell, you can do it as we did it before. So in this case, my underscore name variable is equal to $1, and you could actually test that if you wanted to, and then if you enter that in, it'll say howdy, and then it will print that variable. If you want to read the input during script execution, you can use the read-p command. So read-p, and then some text. This is what will show up when it asks for the input, and then the variable that the input will be assigned to will be shown here. So in this case, it's asking for, this little script is asking for a username and password. The S command makes it hidden, so when someone types their password, it won't be shown on the screen. And so if this is run, here's an example of running this. It'll ask for this input, name, colon, and then someone types in Amy, and then they type in their password. It's hidden, so you can't see it. And then it'll say thank you, and it'll output the name they typed. We have your info. So pretty straightforward. Yeah, so just using this, you can add some basic command line inputs, either via arguments or via like requests for inputs while your script runs. Okay, loops. So a loop is where it repeats a command until a specific condition, and then it will stop. So two ways to do that here. You can do a while loop, or you can do a for loop. So while, and then you'll have some condition, do some command, and then done just tells the script where to end. You could do for. So what for is going to do is it's going to read through every variable in a certain list. So if you look on the right-hand side, this says for file in wildcard.log. So that's going to go for, it's going to iterate through every file that ends in .log. So if you had, file1.log, file2.log, it would repeat that command for all of those files. You could also have it iterate through something like an integer. You could say for file, or for some variable in, like, and then you could have a list like 1, 2, 3, 4, just a list of integers, and it would repeat these commands for the variable being each of those integers. And then for is also ended with done. The while loop, when you're doing some test, once again, make sure you watch the spacing after these brackets, or it could cause some errors. So in this script up here for the while loop, we initially assign I to 1, and then it says while I is less than 100, do print I equals the variable I, and then double parentheses I++ will tell it to add 1 to I every time it goes through this loop. So basically this will just increase I by 1 every time it goes through the loop until it is greater than 100, and then it will stop the loop. So basic while loop example. Okay, so let's do a simple practice, and this one might take a few more minutes, so maybe 5 or 6 minutes to try this one. But we want to write a simple number guessing game in a script. You can call it guess.sh. I think I called my solution loop solution, but call yours guess.sh. So when the script is launched, a random number between 1 and 10 is generated and should be stored in a variable called a random num. The script will then expect some input from the user. So you should use this bottom one, read input during script execution, to get some input from the user and store that into a variable. If the input from the user is not the same as the random number, it should continue to ask the user for an input until the user guesses the number correctly. So hint, to generate a random number between 1 and 10, you can use this command here, and that should generate a number between 1 and 10. If you wanted to run this with an executable, you could change the permissions here on the end of the file, or you could just run bash in the name of the script. So actually, or you could run this. Okay, so we'll take 5 or 6 minutes and try this. If you need a hint, you could ask, or you could look at the solution I have, and then we'll go through it. All right, so I'll walk through this example now. Hopefully, I mean, once again, sometimes there's a couple different ways to do the same kind of thing, but you can look at my solution, and if you weren't able to get it, hopefully this gives you some hints. So I didn't call mine guess.sh, sorry, I called it loop solution. So first thing I did is I asked for an initial input. So this is the guess that the user will input. And then I do the previous command, which was kind of given in the hint on how to generate a random number between 1 and 10. And I store that as this variable random number. The guess input value is stored as the variable guess. So then I have a while loop. So while the variable guess is not equal to the variable random number, it will say incorrect, and then it will ask for a new guess. And then eventually, if guess is equal to random number, it should end the loop. It'll say match, and then it will say the random number that you found. So, and once again, there might have been a couple different ways to solve this problem, but this is just what I did. If we run this, it'll ask for a guess. I don't know, we'll just say 2. Apparently 2 was incorrect. Maybe it's 1. Okay, well, looks like it was 5. So eventually when I got the right answer, it said match. And so yeah, that was my solution. If anyone else had a solution they'd like to share. All right, but yeah, so hopefully, using basic loops and if-then statements, now you can really start to generate very useful scripts, and you can do simple, applications like this, or you can, I don't know, use it to automate tasks. Okay, if anyone has any questions on loops, please post in the chat. If not, we can move on. So I put this command in here because I think it's very useful, especially when you're writing scripts that might need some simple calculations. So BC stands for basic calculator. So it's a command line calculator that can be used for quick calculations. And you can also use it for arithmetic operations in bash script. So here's some examples. And actually, I'll see if I can show some of these. So you can copy and paste this into your own terminal if you want to test it, but addition, subtraction. So we want to get the answer. So you can use this just purely as a calculator if you type in BC, and then you can use it just as a calculator. See 13 plus 3. Oops, how do you quit? Okay. But if you want to use it, within a command, then you do pipe, your command and then pipe BC. So echo 13 plus 3, and then pipe that to BC. And then you get the same output, 16, like that. You can do some different things. Here's exponentials. You can assign this to a variable. So I could say x is equal to the output of this command. And echo x, and it gives the same thing. You can also use this in a calculation. So what would you can use the variable in a BC calculation. So what would I get if we tried this? So in that way, you can use that. So now you can, do basic arithmetic with variables and use that in your script, just using this command. So very useful, and definitely something I wanted to have in here. Okay, so let's do a short practice with this, and this should only take 2 or 3 minutes. But in this script, start with a variable I is equal to 1, and then do a loop that's going to add I plus 2 to I 12 times or some number of times, and then print I each step of the loop. So try to do this using the BC command, and then see what the final number is. And if you get the final number, you can post it in the chat, or if not, in maybe 2 minutes, I'll show you the solution I had for this. So in this case, I'm using a while loop. I think as a hint, when I did this, I made another variable just as a counter to count when I reach 12 times. I just want to make it clear that in this script, you're adding I plus 2 to I. So you're not adding 2 to I, but I plus 2 to I. So it should be quite a large number after 12 iterations. I'll show you my solution. So this one was just under the file bc_solution. Okay, so I start with 2 variables. One is I, and one is just a counter, so I know when I have iterated through my loop 12 times. So here's the basic while statement. So while the counter is less than 12, do, and then add 1 to the counter. And then I is going to be equal to I plus 2 using basic calculator. Then we'll repeat that. So pretty simple, and maybe this could have been done in some different ways, but this was just my first go at it. So you can see this in that file, and if I run it, you can see after 12 iterations, it's 6,142. Okay, so pretty simple, but now hopefully you see how you can use BC in your scripts to do some arithmetic, and you can use it for some different things. It's really quite useful. Okay, so lastly, we'll talk a little bit about customizing your bash environment. Okay, environment variables store information that is used in different processes in a Linux system. So generally, we store these in all caps for bash environment variables. And then if you're going to make your own custom variables, you usually use lowercase. So 2 very common ones that you'll use are home, which is the path name of your home directory, and path. So this is where if you want to execute a command without having to navigate to the directory where that command is located, you'll have to store its information in the path variable. Okay, so echo will show you the contents of a variable. So echo home. So let me try that on here. So you can try this, echo, and then home. And it'll tell you your own home directory. So here you can see mine. You can try that for your own. But yours will probably be similar, just the difference will be the net ID. Okay, the search path. So path will locate commands typed into the command line. So the value of path is a colon separated list. And you can see that here in this blue box as an example of what a path might look like. Path is searched from left to right. So if the command you're typing in isn't found in any of the listed directories, you'll get an error message. If it's found in multiple of these listed directories, it will use the first one, going from left to right. So something to keep in mind if you have commands with the same name in your path. You can add a directory to your path using export. So export path equals and then $path, and then the directory you want to add. Here we can try this now with at least this. You can see my path here. You can try that on your own. This is probably already in your path, so you don't need to do that. Okay, so how can we customize our Linux environment? So there's a couple important files. There is the .bashrc file and the .bash profile file. So the .bashrc can contain aliases, shell variables, paths, as well as things that you want executed upon starting a non-login shell. The bash profile can contain the same things as in the bash RC, but it's normally executed upon logging into the shell. If you want something say a certain command or alias to appear every time you log in to Faster, you'll want to make an edit to your .bash underscore profile file. So if you do dot space and then .bash rc, that's the same as source .bash rc. So that will execute all the commands in your .bash rc file. And same with bash profile. So if you want to find these to edit them, you'll want to pull up your home directory. So if you go to cd and then home, like that, if you just look like in your directory with ls, you won't see it. You have to show hidden files, so do ls-a, and then you can see it here, bash profile, and .bash rc. So then you can open them up with like vi, or whatever command you wanted. But yeah, so just so you know, if you're looking for it in your home directory, make sure you show hidden files with ls-a to see it. Okay, so here's an example of a .bash profile content. So the first section here will source your .bash rc and get anything that's stored in there, any aliases and functions. If you have any specific paths that you want to add to your path, it will, you can put that command here and then add it to your path for all sessions every time you log in. If you want a personal alias, if you want some aliases that you might use, you can add them here with this following syntax. So alias and then whatever the command that you want your alias to be is equal to, and then insert the command here in double quotes. And lastly, if you want a user-specific function, and for example, here is an awk function, you can do that here. So we're going to practice making some aliases and exporting our path using this information. So let's go through this practice. So add a simple alias in your .bash profile. Actually, I shouldn't have done that. Name simple that will execute a command that just prints out a statement, I succeed in creating an alias. Activate the alias. Type in simple at the prompt to use your alias. And then we're going to create a file, and then we're going to add that file to our path. I think I'll do this one with you all as you do it. So we'll just kind of follow along here. So first I'm going to open up my bash profile. So you can do vi, and then this tilde will tell it to go to your home directory. Open up .bash prof. Oops. I think I messed that up. Sorry. There we go. Okay. So we want to make a alias. So I'll just put it down here at the bottom. And it's going to be called simple. I'm just going to equal something like this. So activate your alias. So you'll have to source it. And then if you type in that command simple, it will execute the echo command and give us our output. So just overview of the steps, open up your bash profile, make the change you want to have, which in this case is this alias command, alias simple equals, in quotes, echo, I succeed in creating simple alias, in quote, and then make sure you source it. If you don't source it, it won't work. So you can do .bash profile or source .bash profile. Either will work. And then after you do that, you should be able to run your alias command. And so if you can create a lot of aliases if you want to store a lot of commands to variables. Like what I did is I replaced more with m, so I can do more Oops, actually, I guess I don't have it on faster. Never mind. I think I have an alias for replacing sbash with q. So I have an alias when I type q. It does the same thing as if I would have typed sbash. So, whatever you find useful, you can make aliases for that way. Okay, now we're going to add something to path. So make a directory named my apps. If I don't already have one. Okay. We'll create a file in my apps with the following content. So vi, we'll just call this file, just call it f.sh. So echo, I succeeded in adding my apps to my path. Okay, so now it has that content. I'm going to change the permission so I can run it as an executable. So I usually do 755. You can also do u plus x. So now this can be run as an executable. If we ran it, it would execute that and print our statement. We will, if I navigate out, like if I try to just run f.sh or navigate out of the directory, it won't run because it can't find our command. So let's add this to our directory with export. So should go back here so I can make sure I don't mess this up. So you'll want to run something like this, except with the path to this directory. So here's my path. If you type pwd, you'll get the path. So path equals I guess I could just type this in like this. My apps. That'll work. So now you can see if you echo your path, it should be added here at the very end. And then I think it wanted us to try to run that. So now if I try running it, yeah, so now it works. So now I can run it from anywhere, even if I'm in my, say, scratch directory. Oops. I run my command, I will see this here. And I just changed the path for my current session. You could put the path, that path command in your bash profile, and then it would work for all your sessions. Okay, so here you can see on this slide actually the solution to that. And maybe this is a little more efficient. They just added this to their bash profile here at the very end, activated it, type simple, and that made the alias for making the path. You can follow these instructions here, make a directory my apps, write this file to your file name, chmod u plus x in the name of your file name, and then if you run it, it'll say command not found. However, if you type export path, you can export that to your path, and then it should run. Do anyone have any issues with these? If you did, please let me know. Or you can look in the post solution, which is on the slides. All right, well, if not, that is the end of the intermediate Linux course. So just to summarize, we covered some advanced text processing, basic bash scripting, and then a little bit about customizing your environment with variables, aliases, and editing your path. So I hope everyone learned something today. If you ever have any issues, with the material covering this course, feel free to reach out to our help desk. and you can submit a ticket there if you have issues running your jobs on Faster or ACES. So that's the end of our course right now. I'll stick around for a few minutes if anyone has any questions. If not, then we will end it here. Thanks, everyone.